All right, so this is the problem we left off on. This was part of the, let me go back here, the integrals of the trig functions, which we have those formulas for those integrals. And we're working on this one. And what we did here, we let u be cotangent of t, and then the derivative of that was negative cosecant squared of t, which we have in the numerator. Okay, so the way we're going to write this then is negative integral of 1. We get this situated. This will be 1 over u du. All right, so let's see. We've got the negative du, and that was our cosecant squared t. That's accounted for. dt. I forgot my dt on the end there. Give yourselves a quarter point for that. And there's the dt. All right. All right. And then we got the 1 over the u. We said the u was the cotangent. So everything's accounted for. But writing it like that now, we got a really easy integral to solve. Get rid of all that highlight. And that's just going to be negative natural log of cotangent t. Well, let me do the intermediate step first. So it's the negative natural log of u plus c. And then the last step would be to fill in the u. So put the cotangent t back in there. Let's see. All right, let's take a look at this next one. This is a definite integral, so we're going to have to deal with the limits on this one. Let's see, we have cosecant, which we know what the antiderivative is. We've got cotangent, we know what the antiderivative is. We have to deal with the 2 theta. Right. So we're going to let u be 2 theta. Then du, the derivative of that is going to be 2 d theta. All right, there's no 2 out in front of the parentheses, so we're going to multiply both sides by 1/2 to get rid of that. Okay, so this is going to be 1/2 the integral of cosecant u minus cotangent u du. And we have direct antiderivatives for cosecant and cotangent, so we can do that. And then we're going to need to change our limits. So the upper limit, and when you're changing your limits, you just use how you defined u. All right, so it's 2 times theta, so the upper limit is going to be 2 times pi over 4, which is pi over 2. And then the lower limit will be 2 times pi over 8. which is pi over 4. All right, so we'll just make this pi over 4 at the, I'm sorry, pi over 2 at the top, pi over 4 at the bottom. All right, now we're ready to solve this. We're going to need room here, and I might run out of room. Okay, so we got the 1/2 out in the front. All right, so we want the antiderivative of cosecant is cosecant cotangent, negative natural log of cosecant u plus cotangent u. And then we have minus cotangent u, and that antiderivative is the natural log of sine u. Okay. And then we need to go from pi over 4 to pi over 2. All right, so now what do we have to do? We have to substitute that pi over 2 into everything where you see the u, and then minus, and substitute the pi over 4 in anywhere you see the u. Okay, so this is going to be 1/2. Use braces here because we're going to have two sets of brackets. One for substituting in pi over 2, which we'll do here. Okay, so there's the upper limit, and then minus the lower limit. So substitute in pi over 4 now. That's supposed to be a, let me clean that up a little bit. Looks like parentheses on one side and absolute value on the other. There we go. It's a little bit better. And close off the bracket and braces on the outside. Sorry about that. That was a lot to get in there. All right, now we gotta somehow clean this up, which I think we can do. Don't do anything with the 1/2 yet, just keep it outside the braces. All right, let's do that first bracket. We have negative natural log of cosecant of pi over 2. Cosecant of pi over 2 is 1. And cotangent of pi over 2 is 0. Okay. And then we have the natural minus the natural log of sine of pi over 2. Sine of pi over 2 is 1. Okay. Now we'll go to the other bracket. So don't forget the negative natural log there. Cosecant of pi over 4 is 2 over root 2, which is root 2. And then cotangent of pi over 4 is just 1. Okay, and then we have minus natural log of sine of pi over 4, which is root 2 over 2, bracket, brace. All right, let's see what we got here, cleaning this up. All right, so first we have negative natural log of 1. We don't need the absolute value anymore because 1 is a positive value, minus natural log of 1. Well, those are just 0, right? For both of those. And then, let's see, I'm going to go ahead and, no, let's not do that yet. I was going to distribute that negative, but we'll wait on that. All right, so here we have, I don't think we can do anything with root 2 plus 1 except put it in parentheses because we know it's positive. And then natural log of root 2 over 2. Can't do anything with that, but we can put it in parentheses because it's a, oh, I need my natural log on that. I'll forget that. Natural log root 2 over 2. Close the bracket, close the brace. All right, so we got 1/2. This whole first, I'm going to go ahead and write it in anyway. We'll do an extra step. It's no problem. This whole first bracket is just negative 0 minus 0, right? Because you got natural log of 1, natural log of 1. And then I'll distribute the negative now over here. So this will be plus natural log root 2 plus 1 minus, oh wait, that's also going to be plus natural log root 2 over 2. Okay, so I did get rid of that bracket there. And I can get rid of that whole first term now. That's just gone. All right, so I got 1/2 of natural log root 2 plus 1 plus natural log, oh, I'm going to distribute that 1/2. Let's just leave it in a bracket for now. Because I was going to do something else. Since we have 2 natural logs added, remember that's the same as combining them by multiplying. So you got root 2 plus 1 times root 2 over 2. So we have 1/2 natural log. Let's see, that would be 1 plus root 2 over 2. And that's your final answer. So that one took a little bit of time to get through, but you might see something like that on WebAssign. So hopefully that helps prepare you for that.